What's going on, guys? Okay, so today, Thursday, 9/24. What we did today in class? So what we did is we went and we talked about. All right, we're gonna have a test coming up soon, and so we shut it. So while we're doing this. This was the first thing that we did. All right, so the test is going to be on speed, velocity, distance, displacement, and how to read a position time graph. And then what we do today on acceleration and a velocity time graph, which we'll get into. But so today, this is what we kind of dealt with first. Talking about this guy Tom, his journey from his home to a bus stop on a straight road. So from the other day, what we kind of were doing, we were talking about what your positions are, what XF stands for, XI, so final position, initial position, and you have your time. So position is going to be where you are at any given time. They want us to describe what happens over this journey. You should include the distance covered, how much time, if they change directions, if they stop. So you guys are going to do that. Remember, positive slope moving away from your starting position, negative slope moving back towards, okay, going back away. All right. When you go from a positive slope to a negative slope, it's indicating a change in direction. A flat line is indicating that you're stopped. So what you're going to be essentially doing and typing out and writing is that Tom walked, let's see, he walked 100 meters, all right, because he went from 0 to 100 meters. And it took him 50 seconds. So Tom walked in the positive direction, 100 meters in 50 seconds. And then he turned around and he went how much? Well, he went from 100 to 40, which is a total of 60 meters. So he went back 60 meters in 20 seconds because he went from 50 to 70. Changed direction again and is moving in the positive direction. And he goes from, let's see, he went from 40 to 160. Then he walked 120 meters from 70 to 100, 30 seconds. And then he had stopped. He had come to rest for the last 20 seconds. So you're going to basically write that stuff out, and you're going to, hopefully you guys are able to understand that and just be able to answer that yourself. Then I ask you guys to calculate the velocity for each slope here. So calculate the velocity from the first 0 to 50 seconds, 50 to 70, etc. Your equation is here. Velocity is equal to your final position minus your initial position over time. So for example, if I showed you letter B, 50 to 70 seconds. So the second piece of your time frame or your time interval, that is going to be where your final position is located. So for the 50 to 70 second segment, we're looking at this downward slope. So I go to 70 seconds, I go up. Where's my final position? Well, if I go across, I'm at 40 meters. My initial position would be at the 50-second mark. So I go to 50 seconds, go up, and go across. I'm at 100 meters. Okay. So then what you would do is you're just taking your information and plugging it into the equation here. So XF minus XI, so it's 40 minus 100. Then you're going to divide it by the time. What is the time? Well, from 50 to 70 seconds, that's a total of 20 seconds. So you play that out. Okay, it's going to be negative 60 divided by the 20 seconds, and you should get a velocity of negative 3 meters per second. And just do me a favor, guys, and highlight your answers there in red. Excuse you. There you go. Do the same thing from the 0 to 50, the 70 to 100, the other guy. Do a question I had gotten, do I need to indicate the directions? Not for this one, because when we get a positive velocity, that's telling us that we're moving in the positive direction. The negative sign will tell us that we're moving backwards, okay? And because we're on a one-way street or a straight road, we're not indicating north, south, east, west. All right. So the next thing that we're dealing with. Okay, so we're talking about acceleration. So essentially, guys, acceleration is, all right, the change in velocity over a certain period of time. All right, how it's worded right there is how quickly the velocity of an object is changing. So it's the change in velocity over a certain period of time. So how can you change velocity? What is velocity? Velocity essentially is speed with a direction. So you can change velocity by changing your speed or changing direction. Now, the most common thing we think of when we think of as acceleration is speeding up. That is one way to accelerate an object. All right, you're changing speed, you're speeding up in a certain period of time. You probably heard the term deceleration, which is pretty much, it is acceleration. We would just, when we do the calculations, it would come out negative. All right, it's slowing down, kind of a deal, or it's accelerating in the negative direction. Then we have, what is the other way? Well, we can speed up, we can slow down. What are the two ways that you can change velocity again? It's changing speed and changing direction. So an object can change speed or it can change direction. And it will be technically changing velocity. Therefore, it is accelerating. So they give examples of what are not accelerating. Okay, constant speeds, constant direction. If you're moving at a constant speed in a straight line, that is a constant velocity. So you're not accelerating. So when you see constant velocity or constant speed in a straight line, all right, not accelerating. Changing speed. So you went from 5 up to 10, okay? Even though you're going in a constant direction, you're changing your speeds in a certain period of time. So yes, you're accelerating. Okay, you're running at a constant speed of 3 miles an hour, wait a minute, but you're turning from north to east. So in that sense, yes, okay, you would be, because you're turning, you're changing direction. Okay, you're traveling along a curve in a car and while slowing down. Okay, so changing speed and moving around a curve. All right, both of which are changing your velocities, so you are accelerating. In this one, they ask you to indicate a position, a speed, a velocity, or acceleration, or none of these. A domestic cat can run as fast up as 13 meters per second. Well, that would just be a speed. You're located at the corner of 3rd and Main Street. Well, that's telling us a position. An airplane moving west at 200 kilometers an hour. Speed with a direction. That's velocity. 100-mile trip taking 2 hours. Well, that's a speed, because speed is a distance divided by time, and there's no indication of a direction there. Drag racer, starting from rest, reaches a speed of 100 miles an hour in 4 seconds. Changing speed. So that would be an acceleration. Okay, you go through and you figure the rest of those guys out. So you'd be able to answer the two ways that an object can accelerate. And then indicate whether it's changing speed here, has a constant velocity, accelerating or not accelerating for these guys. All right. Then we get into the average and instantaneous acceleration. Instantaneous tells us the rate of change of velocity at any one instant in time, which you would normally look at by reading on a graph. What we normally calculate is going to be the average acceleration. So when we do that, we're looking for two different velocities. Well, our starting velocity or initial velocity and our ending speed or ending velocity, which we call final velocity. So it says here in a practice problem, suppose a car is traveling at 10 meters per second, speeds up to 25 meters per second, and it does so in 5 seconds. So find the average velocity. So this is your equation, VF minus VI over T. Again, VF stands for final velocity or your ending speed. VI, your starting speed, your initial velocity. So VF in this thing was, what did you speed up to? What was your final speed? 25. So that would go here in the equation. All right, you can't get those two mixed up or you're going to get the wrong answer. It was traveling at 10, so that's your VI. And then you're going to divide out by the time frame, which is 5 seconds. Here you get 3 meters per second squared. Remember, so you put in these, all right, meters per second squared is pretty much going to be our unit for acceleration. All right, so in order to get the meters per second squared thing, all right, it's control period to get the cursor to jump up. So if I showed it again here, meters per second, control period, it jumps up, press my 2. All right, control period again to get it back down to normal size font, right? Good. The next one. So it says, suppose a car is traveling at 30 meters per second and then comes to a stop in 6 meters per second, okay? Well, the final velocity is 0 because it came to a stop. Now, if something comes to a stop, its final velocity is going to be 0. If it starts at rest or, you know, goes from 0 to that would be your initial velocity, and then that would be 0. All right, and then you got your time. So you're looking through, you're figuring out what variables what, and you plop it into the equation. Yes, you can get a negative acceleration. That's okay. That means it's doing what? Slowing down. So in the next ones, what I'm asking you guys to do is I want you to figure out, all right, your VI, VF, T, and then you're going to do 2 things. Find the acceleration, and then find the distance traveled during that time frame. So in this problem, a sprinter who's starting from rest reaches a top speed of 5 meters per second, or reaches a top speed of 10 in 5 seconds. So with this equation, we can figure out how far he actually moved during that time frame. So starting from rest, that's where the 0 comes from. Getting up to a top speed of 10 meters per second, okay, that's my VF. The 5 seconds is my time, so I plug all those guys in. And then for the acceleration in the equation, VF minus VI. So VF was 10, so I'm doing 10 minus, what is the VI? 0. And then I'm going to divide that out by 5 because that is our time interval there. So 10 minus 0 is 10. 10 divided by 5 is 2 meters per second. All right, to get the squared again is control period, and then control period to get back down. Once you've done that, guys, please highlight your work there in red. All right, and then the distance. Well, we already have the variables we need. We have VI, VF, and T. So you're going to just you would show it like this. 1/2, parentheses, what is VI? VI was 0 plus 10. And then you're multiplying it by whatever the hell the time is. So you're going to plug that into a calculator. 1/2 of what's inside times the time. So 0 plus 10 is 10. Half of 10 is 5. 5 times 5 is going to give us 25 meters. Okay, and you highlight your work, show it in red. Okay, and you go through and you do that with all of these guys. Okay, this one's slowing down. So if it's moving, what it's starting at is your VI. What it slows down to is your VF. So, that is not right. Slows down to 25, so your final should be 25. Now in this problem, I put it in parentheses, but a long distance runner moves at a constant velocity. Constant velocity means your speed's not changing, so your VF and VI are both going to be the same. All right, so doesn't matter, still plug it into the equation, get your answer. Can you have 0 as an answer? That's a possibility. Can you have negative? Yes. All right, if it's positive, you don't need to put the positive. Can you have a negative distance traveled? That is incorrect. You can only have a positive distance traveled. All right, so guys, that's your pretty much recap for the day. All right, see you guys.